Alpha, beta are the roots of the equation x squared minus 2x minus 5 equals to 0. Find the equation whose roots are alpha squared beta and alpha beta squared. So to start this, I will have x squared minus 2x minus 5 equals to 0. Now compare this with the general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. I'm doing this so that I can get my a, I get my b and c. Now on comparing these two equations, since the coefficient of x here is 1, that means a is 1. Now the coefficient of x here is minus 2, so b is minus 2. Now the c here is minus 5. On comparing that equation, I have my a, b and c. I'll use a, b and c to get my sum of roots, since the question says alpha and beta are the roots of the equation, and the sum of roots alpha plus beta is given by minus b over a. So I'm going to have here minus 2 all over 1, and that will give me 2 over 1, and that will give us 2. So my sum of roots is 2. Then I go for my product of root alpha beta, and is given by c over a. Now c over a, I have my c to be minus 5 and I have my a to be 1. So minus 5 over 1 will give us 5. So I've gotten my sum of roots and I've gotten my product of roots. Now I'll go on and find the equation whose roots are alpha squared beta and alpha beta squared. Now before that, another way of getting my sum of roots and product of roots is to compare the given equation x squared minus 2x minus 5 equals to 0. I compare it with x squared minus the alpha plus beta plus alpha beta equals to 0. Comparing these two equations, we have minus here, we have minus here. That means alpha plus beta is 2 and alpha beta is minus 5. So I prefer this second way of getting my sum and product of root, because I will be able to get it more faster than I did here. Now back to the question. The question says find the equation whose roots are alpha squared beta and alpha beta squared. Now since alpha squared beta and alpha beta squared are roots of the equation I'm to find, that means x minus alpha squared beta is a factor, and as a quadratic equation you must have two factors. X minus alpha beta squared is the second factor. Now I'm going to expand this like we normally do for algebraic expression, and after expanding that I'll get the equation. So I'll do that on the next page. I have x minus alpha beta square in bracket and x minus alpha square beta. So I go on with that now. I have x into bracket x minus, I bring down this alpha square beta minus, I take the remaining part here, minus alpha beta square into this again x minus alpha square beta. I'm only doing this just the way we expand algebraic expansions. So we have x square, x times x is x square minus alpha square beta x minus this times this will give us alpha beta square x, and this times this will give us plus alpha cube beta cube, because minus times minus is plus, and this each of these times this will give us this. I can go on. I have x square minus alpha square beta x minus alpha beta square x plus alpha beta all cube. So having gotten that, I can still work on this. I can factorize this. I will have x square minus x, because I can see x common, I can see alpha common, I can see beta common between these two. So x is common, then I have alpha beta is also common into bracket alpha plus beta. Alpha plus beta, because for this to be minus, this has to be plus. Minus times plus minus, and I bring down this. I have alpha beta cube. Now I will recall that before I did alpha plus beta, which is 2. Okay, alpha plus beta is 2, while alpha beta is minus 5. So what I need to do to complete this is to put this here, put this here, and put minus 5 here, and I'm okay. So I'll do that. I have x square minus x into bracket minus 5 into 2 plus minus 5 cube. Alpha beta is minus 5, alpha plus beta is 2. So I'll go on. I have x square minus plus, because minus times minus is plus 10x, and minus 5 times minus 5 times minus 5 will give me minus 125. So plus times minus will give us minus 125 equals to 0. So this is the equation we are to find.